Okay, so now we want to know what controls what a river is going to do. So we're going to find out that a river can erode, it can transport, and it can deposit materials. So whether it is going to be eroding, transporting, or depositing is going to be dependent on some master variables. And so here's our first one, which is going to be the slope of the ground. And so another name for this is going to be the gradient. And we're going to abbreviate slope with a capital letter S. And it's just like the kind of slope that you're used to in geometry. It's going to be rise over run. So the rise is going to be the vertical component. That's going to be the elevation of the river. And then the sideways part is going to be the horizontal distance that the river travels. So if you take the elevation divided by the horizontal distance, then that is going to be the slope of the ground. But you notice that the units are a little bit different, that we measure the elevation in meters, but we measure the distance it travels horizontally in kilometers. So that the units for slope are going to be meters per kilometer. Okay, then the second type of variable that is going to control a river is going to be its discharge. So the discharge is going to be the volume of water that is going to be flowing in a river divided by the amount of time it takes it to do it in. So another name for discharge is going to be the volume flow rate. We're going to abbreviate it with a capital Q. And so there's one way of doing this would be actually to measure that amount of water that is flowing in the river, and then we have a line or something, and we measure with our stopwatch the amount of time that goes by, and then we could measure the amount of water that would physically flow past that line. That's really not a good way of doing it. So another way of doing it is to consider that the volume of water that's flowing could be represented kind of like a rectangular block. So here's a rectangular block that has a length L, and then this side over here has an area A. So that the volume is going to be equal to the area multiplied by the length of the block. So if we divide that by T, so that's going to be the volume flow rate, then we need to divide this side by T. And if we put these two things together, so L would be the distance the water flows horizontally in a certain amount of time T, so that would be its velocity. So then we could put that together and we would say that it's the velocity of the river multiplied by the area of the river. So that's the way that it's normally going to be measured. And so in this picture here on the left, it shows two calculations of the volume flow rate. So the first one has that the depth of the water is 3 meters, and then the going across the river is going to be 10 meters. So that means that the area is going to be 3 times 10 is going to be 30. And then it says that the speed of the river is 1 meter per second. So if you multiply that all together, you get 30 cubic meters per second. So that would be the volume flow rate of the first river there. Now the second river, notice, is deeper. And so it's going to be 9 meters deep, and then it's still going to be 10 meters wide, but notice it's flowing twice as fast. So the speed of the river is 2 meters per second. So when you multiply that all together, you get 180 cubic meters per second. So the second river would have a higher discharge. Okay, let's take a look at one more thing. And these are typical volume flow rates, just to give you an idea for how much water can flow in a particular period of time. Okay, let's take a break, and when we come back, let's talk about the velocity of a river and what it depends on.